Assalamualaikum dan salam sejahtera. We are from Group 5. So today I would like to explain our software assignment, which is single phase full bridge inverter with the SPWM control technique. So basically, inverter is one of the power conversion device that widely used in the world to convert the DC input voltage into the AC output voltage. So some industrial application of the inverter are for the adjustable speed AC drive, induction heating, and the HVDC transmission line. So the output voltage waveform of the ideal inverter should be sinusoidal. However, the waveform of the practical inverter is non-sinusoidal and contain harmonics. So in this simulation diagram, the triangular carrier waveform is compared to the two reference signals, which are the positive and the negative signal. So the basic idea to produce the SPWM with the unipolar voltage switching is shown in this simulation diagram. So the difference between the bipolar and the unipolar is the generator use the another comparator to compare between the inverse reference waveform, which is VR. In the unipolar voltage switching, the output voltage switch between 0 and the VDC and or the 0 and the negative VDC. This is contrast to the bipolar switching strategy in which the output swing between the VDC and negative VDC. So when we use the unipolar voltage switching, the harmonic content of the output voltage waveform is reduced compared to the bipolar switching. In this unipolar voltage switching also, the amplitude of the significant harmonic and the sideband is much lower for all modulation index, thus making the filtering easier. That's all from me. So I will pass to my partner to explain more about our software assignment. Thank you.
Assalamualaikum and salam sejahtera. So first of all, I would like to say sorry because I'm having some trouble with my audio recording. So today I would like to explain about single phase full bridge inverter. So basically, a single phase full bridge inverter is consist of four switches, which is labeled as S1, S2, S3 and S4. The operation of the single phase full bridge inverter can be divided into two conditions. Normally, the switches S1 and S2 are turned on and kept on for one half period, and then the S2 and S3 are turned off at this condition. Then, on the other condition, the S3 and S4 will turn on while keep the S1 and S2 turned off. During S1 and S2 turn on, this is known as a positive half cycle, which is the V load or the output voltage is equal to the input voltage. Then, during S3 and S4 turn on, the output voltage, which is the V load, will be the negative value of the V input. The output voltage will change alternately from positive half cycle to negative half cycle. In pulse width modulated inverter, the input DC voltage is essentially constant in magnitude, and the AC output voltage has controlled magnitude and frequency. Therefore, the inverter must control the magnitude of the frequency and the output voltage. This is achieved by pulse width modulated of the inverter switches, and hence such inverters are called pulse width modulated inverters. The power switches are controlled based on the comparison of control signal and the triangular carrier wave, which are made in a comparator. When sinusoidal wave has magnitude higher than the triangular wave, the comparator output is high, otherwise it is low. The interaction of waves determine the switching instant and commutation of the modulated pulse. This pulse will be sent to the power switches in order to turn on and turn off the power switches. The frequency of the triangular carry wave can be modified from a lower frequency to a higher frequency. If higher frequency is used, the number of pulses per cycle will also increase. At the same time, it will reduce the harmonic content of the inverter.
To get the waveform of VR2 and VC, select Simulate and run PSIM simulation. Select VR2 and VC, and this is the waveform of both variables. This is the sine waveform of VR2 and the triangular unipolar waveform of VC. To get the PWM signal, PWM2, select Screen, Add Screen, and select BSPWM2. And this is the signal of PWM2. From the switching rules, when VR is lower than VC, the PWM is 0, and when VR is higher than VC, the PWM is 1. Lastly, to get the harmonic spectrum of Vout, select Simulate and run simulation. Select Vout, and this is the signal of Vout. To get the harmonic spectrum, select FFT, and the x-axis is set to be linear and range from 0 to 800 Hz. So this is the final signal waveform harmonic spectrum of Vout.
For the simulation result, if we run the simulation, we can see the carrier signal and the reference signal VR1. The range T is between 1.5 until 1.56 seconds. So, we can see that it consists of 3 cycles. Next, this is the pulse SPWM for the carrier signal VC and the reference signal VR1. For the Vout, it will measure the load voltage across the resistor. Whenever the switch 1 and switch 2 is on, the value of the output voltage will become 100, same as the Vs, since it's a full bridge inverter. So, when the S3 and S4 is on, and the S1 and S2 will off, the value of the output voltage will become negative 100 volt.